TZ is easy. A is the coefficient of the term x power 7. So it will be combination of 8, first term in bracket, the second term in bracket. We go with ax power 7. So this is 7, this is 1, this is 7. So from that, we can find that a will equal with 8h. Do the same thing for b and d. So C of combination of 6, 8, x power 6, and x squared equal to b x 6. So from that, b will equal with 28 x squared. Now C combination 4, 8, x power 4 multiplied with h power 4 will equal to d x power 4. So from that, d will equal to 70 x 4. So this is 8h, this is 28 x squared, this is 70 h power 4. Okay, given that ABD, the first three terms of a geometric sequence. So the middle term, which is 28 x squared equal to the product of the left term and the right term. So 8h multiplied with 70 h 4. So we have that h equal to 28 squared divided by 8 multiplied with 70, which is 7/5. Question 6. A, find T1, which the first time the acceleration is 0. So this is the graph of the velocity. The acceleration is 0 at the local max or local mean of the velocity. So it will be here. So just put this function into GDC and find a local maximum. So we know that T1 will nearly 0.395 seconds GDC. B, T2 is the second time that the particle at rest. So the particle at rest, that means the velocity equals 0, but the second time. So this will be the second x-intercept. So put this one into GDC and find the second x-intercept. So T2 will nearly 11.0 seconds. C, find the distance travel from T1 to T2. It will be the integration from 0.395 to 11.0 of the absolute value of the velocity, dt. We have is nearly 7.83 meter. Question 7. Okay, find the inverse function of h. So we switch x and y. We will have x equal with the square root of 4y minus 2. So I square both sides to get rid of the square root. So I have x squared equal with 4y minus 2. So from that, y will equal with x squared plus 2 divided by 4. And the domain of this one will be x must be bigger or equal to 0, because the domain of the inverse is the range of the function. So the range of this one, which is bigger or equal to 0. Next, write down the range of the inverse. So the range of the inverse will be the domain of the origin. So this one. So the range of the inverse will be y bigger or equal to 1/2. Okay, B. Function h intersect with the inverse of it at 2 points, find x coordinate. So function equal with function. I have x squared plus 2 over 4 will equal with the square root of 4x minus 2. So I move this one to the left side, this become minus equals 0. I put this function into GDC and find the x-intercept. I will have x is nearly 586, or x will nearly 3.41. C, find the area enclosed by h and inverse. So it will be the integration from 0.586 to 3.41 of the absolute value of this one. So x squared plus 2 divided by 4 minus the square root of 4x minus 2 dx. It will be nearly 1.89. Okay, now D, find the derivative of h. So it will be 1/2 multiplied with 4x minus 2 power negative 1/2 multiplied with 4. So it will be 2 over the square root of 4x minus 2. Okay, find the value of x so that the graph of h and the inverse will have the same gradient. That means have the same value of the derivative. We have the derivative of function x already. Now we need to find the derivative of the inverse. So Let's write the function of the inverse again, x squared plus 2 divided by 4. So the derivative of this one will be x over 2. So derivative equal with the derivative. So x over 2 minus 2 over the square root of 4x minus 2 equals 0. One more time, put this one into GDC to find the x-intercept. We find out that x nearly 1.77.